Hi everyone in Algebra 2B. We're going to be going over lesson 102 today. And the topic of this lesson is sums of functions and products of functions. So what you are going to see is you're going to be given two functions, probably h and a g, or two functions that will be added together and multiplied by each other. So if you see h of x plus g of x, it's going to be noted as h plus g of x. So you're just adding the two functions together. And if you see a dot in between them or like this, that means you're going to multiply the two functions together. But before you can actually plug in to each of the, or plug your x into this function, you need to make sure that the letter or the number that they're actually asking you to solve for is contained within the domain of both of those functions. So it always says d is equal to something, and you need to make sure that that number fits within both of those domains. So the domain for the new equation is all numbers that were common to both of the original domains. So you have to make sure that the domain for the new equation fits within the original domains of both the h of x and the g of x. So that's something to check before you actually start plugging in, because if you don't, you may actually be solving for something you don't need to. Okay, so looking at 102.1, it says h of x is equal to x plus 3. The domain is reals. Then the slash through the x, or let's just call it 0x, equals x squared minus 6. The domain is integers. Find h plus slash of 2. So they're asking you to solve for 2, but they're asking us to add the functions together. So what I'm going to do is I'm going to take h of x and add it to g of x. So my h of x is equal to x plus 3, and my g of x is equal to x squared minus 6. So if I add those together, I'm going to get x squared plus x minus 3. Now I need to check, does this 2 fit within the domain of both of my individual functions? Is 2 a real number? Well, yes, it is. Is 2 an integer? It is. So that's what I'm going to do. Now what I'm going to do is I'm going to plug in this function. So I'm going to plug 2 into this function, and that would become 2 squared plus 2 minus 3. That would give you 4 plus 2 minus 3. 4 plus 2 is 6, and then 6 minus 3 would be 3. And that would be your result. So you're adding the functions together, and then if you can plug in your function, but that's only if it fits within the domain of each of the individual functions. So moving on, we're going to look at 102.2. This one says h of x is equal to x plus 3. The domain is reals. G of x is 2x squared plus 3 and the domain is negative integers, which means that the only integer you can plug in is a negative integer, so a negative whole number. So they're asking us to do h plus g of 5. So that means I need to add the two functions together. So my h of x is x plus 3, and my g of x is 2x squared plus 5. So when I add those together, I would have 2x squared plus x, and then I have 3 plus 5, which is 8. But now I have to check, is 5 within the domain of both of my individual functions? Well, 5 is a real number, but is 5 a negative integer? It's not, because 5 is a positive number. So that means that we actually can't plug into this function. So therefore, your answer would be either the null set or the empty set. There's nothing in it. So either one of those answers would work. So if this number that you're actually asking to solve for does not fit within the domains of both of these, then you would say that the answer is the null set, or there's nothing there, or an empty set. So it's braces with nothing in it. Now we're going to look at product. It says find hg of -4, where h of x is equal to x plus 3, the domain is reals, g of x is equal to x squared minus 6, and then the domain is negative integers. So I'm going to start with, I have hg of -4. So I'm going to start with taking my h function, my x plus 3, and multiplying it from my g function, which is x squared minus 6. So you have to multiply that out. So we start with x times x squared, which would be x cubed. X times -6 would be -6x. 3 times x squared would be 3x squared. And then 3 times -6 would be -18. So now I have x cubed plus 3x squared minus 6x minus 18. But I'm evaluating for -4, but remember that I have to check, does -4 fit within both of the domains of the original functions? Is -4 a real number? It is a real number. Is -4 a negative integer? It is. It's a negative integer. -4 is a negative integer. So now I have to go and place this -4 into the function. So -4 to the power of 3 plus 3 times -4 to the power of 2 minus 6 times -4 and then minus 18. So 4 to the power of 3 is equal to 64. With 3 negative signs would make it -64. -4 squared would be 16 times 3, which is 48. -6 times -4 would be plus 24, and then minus 18. So all I need to do is I need to go through and add those together. So let's do -64 plus 48 plus 24, then minus 18. Your result is -10. And that would be your answer. Okay, now moving on to 102.4. So it says, find fg of -4, where f of x is equal to x plus 3. The domain is reals, and then g of x is equal to x minus 4. The domain is positive integers, which means that the number that I plug in has to be a positive integer. So when I do fg of -4, I need to multiply the x plus 3 times x minus 5. So x times x would be x squared, x times -5 would be -5x, 3 times x would be 3x, and then 3 times -5 would be -15. Now when I add those together, I get x squared minus 2x and then minus 15. But before I plug in my variable, I need to make sure that this number fits within both of the domains. Well, -4 is a real number, so that does work. But -4, is it a positive integer? It's not a positive integer. So if it's not a positive integer, that means we can't plug -4 in. So our answer is going to be either the null set or the empty set. So either one of those answers would work for you. So that concludes the example problems. Now what we're going to do is we're going to go over these problems. Now I'd like you to pause this video and attempt these problems on your own before pressing play, and I will go over them with you. So the first one is going to be number 4. It says a 70% markup of the purchase price made the selling price of the item $16.66. What did the store owner pay for the item? So we're looking for the purchase price. So this is the equation. It's selling price equals purchase price plus markup. So selling price, number 4, selling price equals purchase price plus the markup. And in this case, they tell us what the markup is. They tell us that the markup is 70% of the purchase price. So this would be selling price equals purchase price plus 70%, so 0.7 of the purchase price. Now they give us the purchase or the selling price, which is 16 0.66 equals PP plus 0.7 PP. So if I add those together on the right-hand side, when I add 1 PP plus 0.7 PP, I would have 1,666 equals 1.7 PP. I would divide both sides by 1.7. So I get 1,666 divided by 1.7 would give me the purchase price is equal to $980. And that is what they wanted to know. They wanted to know what the purchase price was equal to. So the purchase price was equal to $980. Now, number 5 is a similar problem. So if you haven't attempted it, pause the video and attempt it now. But number 5 says the selling price was $16.80. The low price was possible because Audrey and Sam only marked the item up 40% of the purchase price. What did they pay for the item? So number 5, same equation. We're starting with selling price equals purchase price plus the markup. Now for this one, it says that the markup was only 40% of the purchase price. So 40% written as a decimal would be 0.4 times the purchase price. Okay, so now it says that the selling price was $16.80, so 1,680. Now if I add these two together, 1 pp plus 0.4 pp would be 1.4 pp. I'm going to divide both sides by 1.4. So I would do 1680 divided by 1.4 gives me a purchase price of $1,200. And that would be your result for number 5. Now I want you to attempt numbers 7 and 8, which are like the new problems that we just went over. So pause the video and attempt those before watching the video. But it says we're going to do hg of -5 where h of x is equal to x plus 1. Domain is reals. G of x is equal to x squared minus 6. And the domain is negative. So if I do hg of -5, that means I'm multiplying the two functions. My h function is x plus 1. My g function is x squared minus 6. And if I multiply that out, x times x squared would be x cubed. X times -6 would be -6x. 1 times x squared would be x squared. And then 1 times -6 would be -6. So if I simplify that, I would get x cubed plus x squared minus 6x minus 6. And the last thing I need to do is make sure that this number is contained in both of the domains. Well, -5 is a real number, and -5 is a negative integer. So I can plug this into the function, which means that I have to do -5 to the third power plus -5 to the second power minus 6 times -5 and then minus 6. So I'm going to do 5 to the third power. And I know that that's going to be -125 because 3 negatives would be negative. -25 squared would be +25. -6 times -5 would be +30. And then minus 6. So I'm going to plug this all into the calculator. So I have 125. I'm going to make it negative. I'm going to add 25 to that, add 30 to that, and then subtract 6. And that tells me that the result is -76. So I multiplied the two functions together first. Then I made sure that the number that they gave me, it fits within the domain of the original functions. And then I plugged in that number and solved. So for number 8, I have find f times g of -3, where f of x is equal to x plus 4, and the domain is reals. G of x is x minus 1, and the domain is positive integers. So f g of -3 my f of x is x plus 4. My g of x is x minus 1. I'm multiplying those two together, so x times x would give me x squared. X times negative 1 would be negative x. 4 times x would be 4x. And 4 times negative 1 would be negative 4. Now if I add those together, I have x squared plus 3x minus 4. But then before I actually input anything into the function, I need to make sure that, this negative 3 right here fits within the domain of the original. Well, negative 3 is a real number, so that works there. But negative 3 is not a positive integer. So therefore, your answer, again, is either the null set or the empty set. And either of those answers would work for you. So we can't plug it in because it's not a part of the original domains. Now we're going to look at lesson 100 notes for number 9. So this is the equation that we need it to look like. It would be y is equal to plus or minus x minus h squared plus k. This would tell me if it's positive or negative, if it opens up or down. This would be the axis of symmetry, and this is where we start. And then we're going to use this chart to create our actual diagram. So I'm going to start by putting all the x's in parentheses. So x squared plus 4x, and then on the outside I have plus 2. When I complete the square, half of 4 is 2. And when I square 2, that would be plus 4. Remember, whatever I do on the inside, I have to do the opposite to the outside. So if I add 4, I have to subtract 4. And then 2 minus 4 would be negative 2. This positive on the outside tells me that this is going to be a parabola that's going to open up. The x plus 2 squared is my axis of symmetry. So if I set x plus 2 equal to 0, that tells me my axis of symmetry is going to be at negative 2, and this will be my vertex. So at negative 2 on the x-axis, I'm going to have a dotted line right here. And then at negative 2, I'm going to have my vertex. So negative 2 is a dotted line, then negative 2 is where I start. Then I'm going to use this chart right here, which tells me I'm going to go over 1, up 1, and then over 2, up 4 from the vertex. So from my vertex, I'm going to go over 1, up 1 in either direction, over 1, up 1, and then over 2, up 1, 2, 3, 4. Same thing, over 2, up 1, 2, 3, 4. And then I'm going to connect my dots to make my parabola. And that would be number 9. Okay, and then the last one that I wanted to attempt with you was number 10. Again, it's the same type of problem. So what we need to do is we're going to start by putting all the x's in parentheses to complete the square. So this would be y is equal to negative x squared minus 4x minus 2. Before I can complete the square, though, the x squared has to be positive, so I'm going to factor out the negative sign. So that would be plus 4x, and then minus 2. When you complete the square, you take half the term that's attached to x. So half of 4 would be 2. But when I square that, it would be plus 4. But don't forget to do the opposite to the outside. But the opposite on this one, this is actually a negative 4, not a positive 4. So the opposite of minusing 4 would be adding 4. Okay, so when you factor out a minus sign, don't forget to redistribute that before you do the opposite to the outside. So this is a negative 4. This would become positive 4. And negative 2 plus 4 would be 2. This minus sign tells me that my parabola is going to open down. And my x plus 2, I'm going to set equal to 0 to solve for the axis of symmetry, which would be at negative 2. And this right here would be my vertex. So for my axis of symmetry, I go over 2. This would be my dotted line. Then for my vertex, I'm going to go up 2, which will be right there. Now I'm going to go back to my chart, which you do need to have memorized. It should be 1, 1, 2, 4. So over 1, down 1, over 2, down 4. So over 1, down 1 on either side. And from my original, over 2, down 1, 2, 3, 4. And I would do that to both sides. And this should be what your parabola looks like. And that concludes all of the problems that we're going to be doing from lesson 102. Please make sure to post all of your questions for 102A in the comment section of this video. I hope you all have a great day. Bye.